So this is P4 day 2, okay? So this is just more factoring. It's really just additional examples if this is helpful for you. Okay, so first. So generally, sometimes you're told how to factor and sometimes you're just told to factor completely. So first, let's look at 30v to the 7th, x to the 5th, minus 18v x cubed y to the 4th. And if you're just told to factor completely, looking at this, it looks like all we can really do is take out a GCF, right? So our GCF, if you look at 30 and 18, our GCF is 6. As far as the v's, we can take out a single v to the 1st. As far as the x's, x cubed. The y's, well, it's only in one term, so we can't have that in our GCF. So then for this first term, 6 times 5 is 30. V times v to the 6th is v to the 7th. X cubed times x squared is x to the 5th. Minus, let's see, 6 times 3 is 18. V times 1 is v, so we don't have any v terms here. And then x cubed times 1 is x cubed. And then we'll have to have our y to the 4th. So that's our answer. For our second example, let's look at 3v squared times v minus 8 minus 5 times v minus 8. So for this example, it's already kind of partially done for you. It's sort of a halfway completed factoring by grouping. But the idea is, since 3v squared and negative 5 are both being multiplied by v minus 8, we can rewrite this as 3v squared minus 5 times v minus 8. And again, the reason this works is because technically 3v squared is multiplied by this whole thing, and so is negative 5. Next, 3w cubed plus 4w squared plus 15w plus 20. There's 4 terms, so we'll have to use grouping. It's written in standard form, meaning descending powers, which is good. So we'll split into these two pieces. The GCF of 3w cubed plus 4w squared, we can't take out any numbers other than 1. So it looks like we have w squared. W squared times 3w is 3w cubed. And w squared times 4 is 4w squared. Plus GCF of 15w plus 20 is 5. 5 times 3w is 15w. 5 times 4 is 20. These match, which is good. Okay, that's what we need to happen. So then we end up with w squared plus 5. And both of these terms are multiplied by 3w plus 4. Next, 6x squared plus 78x plus 72. So the first thing I'm going to do is check for a GCF, and that's really what you want to do every single time, because otherwise this looks a bit icky to factor, but it turns out we can actually take out a 6. So we have 6 times x squared plus 13x plus 12. And when you're factoring something like this, we know we're going to have 6 and then 2 binomials starting with x. And then using kind of the shortcut, we're looking for what numbers add to be 13 and multiply to be 12. And that's going to be a positive 12 and a positive 1. All right, fifth example, 3x squared minus 14x minus 24. Okay, so you can always use Xbox for these. I believe I said this in Friday's video as well, or hopefully I did. But you can always use Xbox. I like to use guess and check. So I know that I'm going to have 2 binomials. The only things you can multiply together to get 3x squared are 3x and x. And then I want numbers that multiply to be negative 24. So here I'm just going to kind of guess, okay? So let's say 6 and 4, okay? So let's say there's a 6 and a 4. If they're going to be multiplying to be negative, one of them has to be negative, one of them has to be positive. So let's say this is a negative 4 and a positive 6. Let's see if that works. 3x squared minus 12x plus 6x. That didn't do it. Let's switch the 6 and the 4. 3x squared minus 12x plus 4x. I'm sorry, 3 times 6 is not 12. 3x squared minus 18x plus 4x minus 24. That works. Okay? And it might take you longer. If you get really stuck, you can always just use Xbox. Here's another. Negative 2w squared minus w plus 21. So whenever we have something like this and we're factoring, we can't take out a GCF really, but we can take out a negative, and that's just always a good idea. Okay, so let's rewrite this as negative 1 times 2w squared plus w minus 21. Okay, so I'm basically multiplying or dividing, depending on how you look at it, every term by negative 1. And so then, when I have a negative out front, you don't need the 1 anymore. The only things that multiply to be 2w squared are 2w and w. And now it's guess and check again. Okay, so it looks like we're going to add to a positive, multiply to be a negative. So one has to be positive, one has to be negative in terms of going after the 2w and w. I think 7 and 3. Okay, so because 21 and 1 doesn't seem like it'll work. So 7 and 3, let's do minus 7 plus 3. 2w squared minus 14w plus 3w. That didn't work. Let's switch the positive negative. 2w squared. Did I just do this? It's the problem when I talk after I do stuff. Let's just switch the 3 and the 7, okay? So let's make it plus 7 and minus 3. 2w squared minus 6w plus 7w. Oh, that equals w minus 21. Okay, it's not an exact science. Let's keep going. 121y squared minus 4x squared. So when you have two terms and you can write it as something squared minus something squared, that's difference of squares. So I can write this, so 11 squared is 121, so I can write this as 11y squared, and then 2 squared is 4, so minus 2x squared. And I know this factors into, because of the difference of squares, formula, pattern, whatever you want to call it. This is 11y plus 2x times 11y minus 2x. For the next one, let's look at 12z cubed minus 75z. So I see a cubed, which is good. I don't know if I can do anything with this, so I'm going to look for a GCF. I can take out a 3, and I can take out a z, and then I have 4z squared minus 25. And that looks like something I can work with, because I can rewrite 4z squared as 2z in parentheses squared, and then 5 squared. So this is 3z times 2z squared minus 5 squared. So we have a difference of squares in here. So I can write this as 3z, because that has to stay, times 2z plus 5 times 2z minus 5. Now let's do 48u to the 4th minus 3u to the 4th v to the 4th. I mean, let's look for a GCF. I see some u to the 4ths, right? And I see a 3 I can take out. So let's write this as 3u to the 4th times 16, okay, minus v to the 4th. And this I can write as difference of squares. All right, 3u to the 4th times 4 squared minus v squared squared. Okay, So then this is 3u to the fourth times 4 plus v squared times 4 minus v squared. Okay, we see another difference of squares. Or maybe it takes you a second, but so this is technically 2 squared minus v squared, so we have to split that one again. You can tell I'm going to light blue, so we're almost done. 3u to the fourth times 4 plus v squared times 2 plus v times 2 minus v. Okay, that's kind of the longest they get. Let's do a couple more. Actually, 3 more, because I didn't want to make it 11. That seemed like a weird number. 125 x cubed plus 8. I see some cubes, okay? And I can write this as 5x cubed plus 2 cubed. So I can use my sum of cubes formula / pattern. So if this is a plus here, I'm going to start with the first term plus the second term. My first term in this trinomial here is going to be this squared, which is 25x squared. And then using the pattern, we have a minus next, and we multiply these two things together. 5x times 2 is 10x. I have to rewrite that because I write too big. Plus this second term squared, which is 4. I forgot to switch to blue, so we'll just put a little bubble around it. Or cloud, I guess. Okay. Next, 64a cubed minus b cubed. So this is another cubic. Okay, I can write this as 4a cubed minus b cubed. This is very similar to the sum of squares pattern. The only thing different is the signs. So now we'll start with this minus this. So 4a minus b times this first term squared, 16a squared. And then this is a plus. These multiplied together, so 4ab. And then another plus this squared, which is just b squared. Last one. X cubed plus y cubed. This is really the most basic kind. It's already in the format, okay? And so we have these added, x plus y times this first one squared minus the 2 multiplied plus the second one squared.